Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With the launch of their managed Kubernetes platform, it's easy to get started with the next generation of deployment and scaling, powered by the battle-tested Linode platform, including simple pricing, node balancers, 40 gigabit networking, dedicated CPU and GPU instances, and worldwide data centers. Go to pythonpodcast.com/linode, that's Linode, today and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host, as usual, is Tobias Macey, and today I'm interviewing Meredydd Luff about how code completion works and what it takes to build your own completion engine. So, Meredydd, can you start by introducing yourself?
Hi, thank you very much for having me back. My name is Meredydd. Among other things, I'm one of the original creators of Anvil, a platform for building web applications entirely in Python, so no JavaScript or HTML required. I also enjoy poking around with programming language usability, and recently was in Salt Lake City giving a talk about code completers at PyCon, because that's the thing I found myself building and discovered was really, really cool.
And for folks who haven't listened to your previous appearances on the show, can you just quickly give an overview of how you first got introduced to Python?
So, you're going to make me open with one of the controversial things, because actually I got into Python originally via creating Anvil. So we wanted a full stack environment for developing applications that, instead of making you learn 5 different programming languages, let you actually build with a coherent set of abstractions, and that meant one programming language for everything from like your back-end code to your front-end to your UI driving. And we chose Python for this because it's so popular with, everybody from someone taking their first steps into programming to machine learning engineers to the folks who run Instagram. So because of that wide appeal, we reckon that would be a good language to choose. And so I ended up coming in from that end, from hacking on a compiler for it into the Python ecosystem, which is a fairly unusual route in, but it was quite fun.
From that compiler perspective, I'm wondering how much of that experience translated into your current interest in code completion.
Oh, I mean, huge amounts. If you are building a developer tool of any sort that needs to understand what your code is doing, whether that is a compiler, whether that's code completion, whether that's assistance within a development environment, it's all sort of very much scratches the same kind of mental itch. And I imagine that as this conversation goes on, we'll be talking a lot about the overlaps and how that works.
In terms of the idea of code completion, most programmers who have done any amount of development, particularly if they're using a full-fledged IDE, has experienced it in one form or another. But for anybody who has been living under a rock for the past 30 or 40 years, can you just give the quick elevator pitch of what code completion is and why it is useful and some of the avenues in which it will help the developer do their job?
Sure. Code completion is that little pop-up box you get if you're using a development environment like PyCharm or VS Code. As you type, it'll be giving you a little pop-up box of things you might want to type next. It'll help you autocomplete, typically variable names, sometimes other identifiers in your code. I mean, it really is in any modern developer toolkit, and for very good reasons. These days, the average developer uses a huge number of libraries, and code completion gives us discoverability because it lets us see what functions are available in some library module without having to tab over to the documentation. You can just hit, mylib dot and see what it's got. It gives us speed, obviously, because you can type a few characters and hit the tab key rather than taking the time to spell initialization correctly for the 3rd time in this function. It gives us confidence that what you're doing is right, because there are whole classes of bugs that aren't necessarily easy to spot with the naked eye immediately, but the code completer will tell us what's wrong, and so we'll find and fix certain classes of mistakes without ever hitting the run button. For all those reasons, it feels good to use. It lets us stay in that flow state that's really where you want to be as a developer. So yeah, code completion is awesome. You've probably used it. If you hadn't, I'm really interested in what language, what environment you are working in. And if you are still hanging out in Vim with no plugins, at least try the Jedi plugin. Code completion is available to you. You do not have to leave your 80-character text window to enjoy it.
Yeah, and with the introduction of the language server protocol, it's become even more approachable and accessible without having to conform your development environment to what everybody else might be using. And it actually just makes it much easier for you to use Vim or Emacs, or at this point, it's probably available in Nano. I don't know.
I will bet you the next beer that if I Google Nano Language Server Protocol Client, you'll find it. I think standardization of that has been good, although it has kind of standardized everyone onto the lowest common denominator, which I think we'll talk about in a bit.
And so, as you mentioned, you gave a presentation at the most recent PyCon to talk about some of the elements of code completion and how to actually build one, and in fact did create a fairly simplistic one on stage, but definitely an impressive feat nonetheless. And I'm wondering if you can just talk to your overall approach for identifying what the core and fundamental concepts are that needed to be addressed to make it digestible and how to fit them in the time that you had available.
So it's a fairly big subject, and obviously in a half-hour talk I couldn't cover all the intricacies. Really was trying to talk about the basic mechanism, because code completion is one of those things that seems like absolute magic until you actually work out how it works, at which point you realize it's blindingly simple in the middle, and then you can add extra sort of Baroque complications onto the outside. So I reckon half an hour is just about long enough to explain the basic mechanism, how a code completion engine works, and then to prove that it really was that simple by building one on stage in about 5 minutes. And so the real challenge there, I think, was to find like a subset of functionality that's recognizably a code completer, that like hits the high notes, that demonstrates like what a completer does, but is still simple enough that I could write the skeleton of it on stage while chattering without boring the audience to tears. So I ended up with writing a completer that understands, it was variable assignments and function definitions, and that's about enough to get through the idea that your code completer is going to have to look at the code you're writing, work out what's going on in that program, build up some kind of idea, in this case, some kind of model of, what variables are defined at which points in the program, and then when it finds where your cursor is, it's going to have to offer you the right set of choices. If you're inside this function, then you offer local variables that are inside this function. If you're out in global scope, then you offer the global variables, etc. And, it was pretty successful at that. And I mean, as I said in the presentation, and I would hold to now, like all the extensions between that basic kernel and most of a full-fledged completer are actually like pretty mechanical. Okay, right, I understand the assignment statement. Now I need to understand every other piece of syntax in Python, as opposed to any kind of big conceptual leap. So yeah, the goal was to find what the core information is, and the core of building a code completer, which is what's going on in a program, find out where the cursor is and what valid moves the programmer might make, and then find a sort of subset of it that was small enough to build and demonstrate on stage.
In the presentation and earlier in this conversation, you mentioned that you had actually built a completion engine for use in the Anvil environment. And I'm wondering if you can just talk to what led you to attack this problem in anger and actually subject yourself to building a full-featured completion engine, and how naive you were going into it and how much you regret that decision now.
All right. So, okay. I feel like we're definitely teasing the audience here because we're talking around the edges without diving into properly what a completion engine is. But I suppose it's useful to set the scene. So Anvil is a web framework. It's open source. You can run it headless, just download your code and launch the standalone server. But Anvil's editor is an online IDE. And so you are building your user interfaces, writing your client-side code, writing your server-side code, configuring your database, and running and testing in this browser-based environment. Obviously, if you're going to try to make an IDE, then you're going to need good code completion. And there are, as we've previously alluded to, off-the-shelf code completion systems available. So the language server protocol is this sort of network protocol for talking to a standalone program that's offering code completion. And there are a couple of LSP engines for Python. There is Jedi, which is at the core of one of the Python LSP engines, which is an open source project for Python-specific autocompletion. There are a couple of other things out there. And we could have grabbed one of those off the shelf and used it, but Anvil has a couple of specific requirements. One is that Anvil knows about a bit more than your typical IDE because it's a full stack framework, because you've got this drag and drop editor to build your user interface. It knows about what components are on your screen. And so we want the autocompleter to help you with that, to help you interact with those UI elements. And so it's got to know what's in your drag and drop designer. It's also full stack, it's server and client. So it's got to know what's going on the server, so that when you call some function on the server, it actually knows what data you're getting back and can offer you helpful autocompletion. And it knows the schema of the built-in database. So if you get a row from the database, it can autocomplete what columns you're pulling out and that kind of thing. And sure, okay, that's a challenge, but we could have hacked that into something like Jedi. The real challenge is that it's a web-based editor, which means that there's just not a lot of time between keystrokes. The programmer is typing at full programmer speed, and you don't have a few hundred milliseconds to send your code back to the server and run it through a completion engine. So all those reasons for us pointed towards building one actually running live in the browser that we had full control over, so we could make it smart in the ways we needed it to be smart. And so what I did, because I was the original author of this subsystem, is I picked up the Python to JavaScript compiler that's used to run your applications, because in Anvil you're writing all your code, including your client-side code, in Python. And obviously, if you're running that in the browser, then we need to translate it to something the browser understands. We use a JavaScript compiler called Sculpt, Skulpt. And basically, what I did is I cracked it open and pulled out its front end, the bit that is used for understanding code before it compiles it into JavaScript, and used that for understanding the user's code. And then built the logic of working out what the user's program is doing and working out what the valid next moves were, what autocompletion suggestions to present, sort of by hand. It was a challenge. It was a fun challenge. I say, as a developer, it taught me an awful lot. I think that it's one of those things which is 80-20. So the initial results came very quickly, and rounding out the corner cases is an ongoing project. And if you're in a position to draft off somebody else's work, I'd probably say that was worth doing that. On the other hand, a lot of the things we're doing with Anvil, it is very difficult to do still with an LSP-based off-the-shelf autocompleter. So I think we probably made the right choice for us, but we're kind of an idiosyncratic case. So, no regrets, but also not necessarily the right choice for you if you're listening to this.
And so in terms of the actual process of building a completion engine, you mentioned that you ended up having to build this from scratch because you had very bespoke requirements that were customized to your execution environment. I'm wondering if you can just talk to the actual core elements that are necessary to be able to tackle such a problem where you don't have prior art to be able to build on top of.
I think it will be a bit grandiose to claim this isn't prior art. People have done this before, but let's zoom right out. If you're building a code completion engine, start by thinking about what it's got to do. Because you're writing a program, and its job is to be presented with a half-written program from the user's text editor that's got a cursor somewhere inside it. And it's got to sort of answer what might the programmer type next. It's got to work out sort of what the valid next moves the programmer might make are. And to do that, it's got to understand that half-written program. And this is a huge challenge if you're just thinking about this thing as a bag of bytes you've just been handed. But this is also a bit of a challenge for something like a Python interpreter if it just thought of the program as a bag of bytes it's been handed. But actually, if you run a program in Python, the Python interpreter opens your .py file, it reads it in, but it doesn't read it in by byte, executing each command as it goes. What it does is it reads it in all at once, and it's got a piece of code that turns this text into a more tractable representation. So there's already a program for understanding programs. It's called a parser. And you can sort of think about it as a black box that you load a bunch of bytes representing a program text into the front, and then it will spit out at the other end something called an abstract syntax tree. So this is a set of objects that represent your program. So, for example, you might have a function definition object. It will have, some objects representing the arguments, what names those arguments have. And then it might have a list of statement objects for, what statements are in the function. And if there's an if statement inside there, well, there will be an if statement object with statements for one end and the statements for what's in the else block and so on. And that set of objects is much easier to walk over in code. So what you can do is you can take the half-written program the user's given you, you can feed it to the parser. Ideally, you'd replace the cursor with some special symbol, and then you would feed this half-written program to the parser and get your syntax tree out. At which point you can walk through the program, building up a representation of what's going on. So, every time you see in Python an assignment to a variable named x, well, now you know there is a variable named x in this scope. And so as you wander through the program, when you encounter the cursor, if that cursor's in a position where it might want to type a variable name, well, you know that x is one of the options that the user might want to type next. And this basic process is pretty simple. It's even simpler in Python because we have access to the AST module, which is part of Python's standard library, and it gives you access to the Python parser. So you can call ast.parse, then you give it a string of Python code, and it will give you that bunch of objects that represents your Python code. And so what I actually did in the talk as a demonstration was to take a program that I already had written and running with a code editor, where every time I triggered the code completion, it would call this function with the text. And I fed that text into ast.parse. I walked through the statements that come out of that AST, built up a representation. Every time I saw a variable assignment, I went, oh, well, that variable must be in scope. And then when I saw the magic cursor symbol, I just offered all the variables that were currently in scope as potential completions. I say that took less than 5 minutes to build end to end. So the basic components to build a completion engine, to get back to your question, a parser. That's pretty much it. If you have something that will turn the bag of bytes you're getting out of the text editor into a structured set of objects that you can loop over, then 90% of the battle is already won. And it's just your job to walk through the program thinking, for the completer you are building, what information the program is going to need to know at the time you hit the cursor.
In terms of the opportunities for improving the overall capabilities and kind of enhancing the developer's experience, beyond those core elements, what are some of the other opportunities for customization and improvement, and some of the ways that somebody might think about extending an existing completion engine to fit a particular domain or specific use case? Like, for instance, if they're trying to add some DSL component to a development environment to address the needs of their end users.
So I think I've already talked about this from Anvil's point of view, is that what sets Anvil apart is that it's full stack, and so the code completer wants to know about more. It wants to know, in Anvil's case, about what's in your user interface. But really, this is sort of extensible to anywhere where there is structure that's not necessarily part of the language that you might need to know about. And really, the opportunity that you get from customizing your completion engine or building one from scratch is that you get to build that knowledge into the completion engine. So just as an example, the Anvil's code completer knows about the schema of your database. And so Anvil has a sort of object database that you can access. It's all in Python code. You don't generate SQL, because generating SQL in Python is almost as bad as generating JavaScript from Python. Not quite, but almost. And so the types, if you're searching a database, the keyword arguments you might have depend on what columns are in your database. And that's not information that is readily available to a code completer that can just see your .py files in a typical code base. So the opportunity for us there was to inject knowledge from outside just the Python source code. For example, what arguments that function takes, what keys are in the dictionary it returns. There's a sort of analog, actually, for this. So, okay, I'll go for the rant I'm itching to. So the big problem with the web, that code completion really brings to a point, is that if you're building a typical web application today, you're building effectively two programs. One program that runs on the server with maybe Python and Django, Fast API or whatever you're using, and then one that runs in the user's web browser, built with JavaScript and React or Redux and Bootstrap and whatever else is in fashion this week. And those two programs have to talk to each other. Now, they pass data to each other an awful lot of the time. That's the main data path of your application. But if you're just analyzing the .js source code of your front-end code, you don't really know what shape of data is coming back from one of your HTTP requests that goes to the server. And so there's actually a limit to how much your code completion can really offer. Your code completer really needs a bit more information about what's going on the other end of that HTTP request. It would ideally, when you fetch something from an API endpoint, it should be able to autocomplete the attributes on that object. Now, currently, the best that the world has got to, which is, this is better than it used to be, better than it was 5 years ago, certainly, is there's a specification called OpenAPI, which is a way of encoding, basically it's type information for HTTP endpoints. And this is a YAML or JSON file that, if you're using certain frameworks like Fast API, you can actually pull a lever and just get it out of your server code. These are the arguments that all these HTTP endpoints are expecting. This is the shape of data they will return. Sometimes you have to write that up by hand, but you can get this machine readable specification. But unfortunately, really, the current state of the art is you then feed that JSON file into a code generator like Swagger, and then Swagger will spit out a bunch of .py files as a sort of library on your disk, and then your code completion engine will walk over that library, and then it can offer you some kind of code completion on what's coming back from your API endpoints, which it works. And it's better than not having code completion on your application's main data path. But really, you could say that whole really quite laborious, complicated process that requires a ton of automation, that's really mostly a workaround from the fact that your code completer doesn't know what's going on the server. And if that code completer could have knowledge injected into it about what's coming off those HTTP endpoints, then you could write the simple code with just the requests library or something like that, and you would still get the quality of code completion you'd get off, the huge amount of Python generated by Swagger. So, what's the advantage of a code completer being smarter in the ways that building your own currently allows you to be smarter? Well, it lets you provide the programmer with assistance without having to go jump through hoops of code generation.
Taking that a bit to the extreme is the example of what GitHub recently released with Copilot, where they say, we're going to analyze all of the source code that we can find and generate entire program fragments or function definitions for you so that you don't have to know about it. And of course, in some cases, great, that sounds amazing. And in other cases, oh my God, that sounds awful.
Yeah. So, I think Copilot, it's a different sort of beast to parser-based code completion. Copilot is basically running your code through a great big language model, GPT-3, I think, or derivative of it. And that's it's spooky how good it is sometimes. It has some kind of semantic understanding in scare quotes here, but some kind of semantic understanding of what's going on in your code, and it can suggest sort of, whole functions of code all at once. But it's not really the same thing as what are the valid moves I might make next as a programmer. Parser-based code completion is really good at, I've typed X dots and it knows all the attributes the X object has. And so it's giving me a kind of complete list of the valid next moves. Whereas something like Copilot gives you an option chosen with a certain amount of inspiration and a certain amount of chance, which is, it's useful, but it's a very different experience. It's not Copilot is not going to burrow itself back into your brainstem like a code completer is. It's not going to become part of, I'm not even thinking about using this. It's a different sort of thing. It's really cool, but it's not the same thing as classic code completion, I'd say.
Digging a bit more into what you were talking about of the various signals that you can use to be able to understand what are some of the valid inputs. Obviously, in Python, there is the abstract syntax tree. I can analyze the source code in the file that I'm editing. I can spider across the repository to understand what are all the other source code files that I might be dealing with. I can understand the import mechanisms to be able to say, okay, now I'm going to see that I need to understand what is being imported so I can spider my virtual environment to understand where all the tokens that are in there. But if I don't have that virtual environment populated on disk yet, then I have no way to understand what those imports are actually bringing in. And then in another direction, there's what you were saying about some of the API endpoints that I might be pulling to draw in different JSON payloads that have their own structure. And, now I need to go and find the JSON schema that hopefully exists somewhere so that I can load it in and tell my editor this is where it lives so that it can understand that it needs to add that to my code completion signals. And then there are opening up another potential can of worms here, the aspects of type hinting in Python to be able to say, okay, this variable X is actually of type foo, and I know that foo has attributes, bar, baz, and quux. And so I'm going to say, if I have X, then I know that I'm going to provide, a suggestion for bar. So just wondering if you can talk through some of those other different elements of the types of signal that you might need to bring in and some of the extra machinery beyond just being able to parse the file that I'm editing right now.
I mean, I think you've offered a pretty good survey of them, really. It's about pulling other types into the module you're currently editing. And I mean, honestly, I think you've gestured towards some of the big class of solutions for each of them. Really, I think that the core of all of this is the ability to parse a piece of Python code, walk through and learn some things about it, like, what type of thing does this function return? And absolutely, one of the ways you can learn that is by inferring it from code. What to do when the type annotations disagree with the code is another of these fun questions. There was a rather vituperative article a couple of weeks back about somebody getting very disillusioned with Python typing because in their experience, it was leading them wrong as often as it was leading them right. I don't think that's a majority opinion, but you do have to answer questions like, I'm pretty sure that, you've declared this thing as :int, but you just assigned a string to it. What am I going to do now? Although actually that does lead us on to one of the other functions of code completion, which is that it's not just about working out what the programmer might type next and popping up that autocomplete box. Because if you're scanning over the code, then already doing the pass of understanding what's going on, which means that you can often highlight sort of syntactically valid, but did you really mean to do that moments? Like, for example, you've declared this variable as type int, but you just assigned a string to it. Are you sure? That's valid Python, but are you sure? Or you've just defined a function inside a class definition and you haven't called its first argument self. Are you sure you meant to do that? Valid Python, but it's questionable practices. And I think that's one of the great things about it, is that you can do all sorts of analysis. I mean, there are programs that, scan your code and try to detect bad security practices, and they do very similar things as well. Once you've got your code as a syntax tree, you can really go to town on it. But yes, I think you did a pretty good survey, honestly, of the sources of information you might want to be bringing in. There's a bit of a challenge there when you're using sort of large libraries of stuff, because obviously you don't really want to be reparsing everything on every keystroke. And so you end up doing what's classically referred to as an index. So you'll build some kind of data structure that represents the things you know about the other pieces of code that you're not editing right now. And then you will use those to answer questions in the code completer. So, you reparse all of the requests library every time someone edits a piece of code that uses it, but you will know that they've done import requests and they've done requests dot, and you know what the possible answers there are. You know that if they type request.get and then they want to, command click on that to jump to code, you know where that function was defined and so on. But it's, again, I think something like indexes runs into one of the classic problems with doing code completion, especially in a language as dynamic as Python, which is that all of this is always an approximation. It is a perfectly valid move in Python to import requests and then go requests.myNewFunction equals foo. At which point, technically speaking, every other piece of code in that interpreter has a new function in the requests package if they've imported it. And your autocompleter has to work out, well, am I going to support that? Because sure, that example was quite malformed, but your typical class in Python, we only know what attributes are in that class because the dunder init method assigned a bunch of attributes to self. There was no declaration of what was coming. So it's all very dynamic, and we do have to infer a lot, and we kind of have to work out, well, if I see somebody, abusing another module or assigning an attribute of another module or variable in another module, do I update my index for everybody who's using that module? Do I say, well, you're being naughty, so I'm just not going to help you with that naughty thing you're doing? It's all approximation, really. On a fundamental level, in a language as dynamic as Python, it's always mathematically impossible to know for sure what the code is going to do before you execute it. That's the halting problem. That is true of every programming language. But in Python, because it's so dynamic, that means you don't know for sure even what functions are going to be defined in this file. An autocompleter is always guessing. It's always putting a wet finger in the air and going, well, I'm pretty sure this is what's going to happen. And that's kind of okay, because code completion, I like to say it's a little bit like building the graphics for a computer game. You do not need perfect physical realism. Perfect physical realism isn't the point. The point is that there is a human in front of that keyboard and you want to keep them happy. And so when you encounter something funky, like someone monkey patching an extra function onto the requests library, it's a pretty rare case when that happens. So as long as you handle most of the things correctly most of the time, most of the people are going to be happy most of the time. It's one of the reasons why I said earlier it's a sort of 80-20 game, that actually the first bits of work get you a lot of benefit, because most of the time people don't do silly things. And so most of the time, the straightforward strategies for all the sources of data you were suggesting basically work.
Once you have that initial 80% of this does the majority of what I want, it will pull in the different signals that I need. And now I want to add that extra few layers of polish to actually make it an enjoyable experience and provide real utility to the end user. What are some of those elements of taking I have a basic completer working to I have a basic completer working that I am confident as labeling production grade and, is generally useful? Thinking in terms of things like I have malformed Python that is not parsable, but I still need to be able to give some input, or I have multiple different signals of where this symbol might be coming from, or, multiple possible completions of this, text fragment. How do I understand priority ranking of which one to suggest first and things like that?
I think this question is really back to basics. This is not about, how I'm gathering signals for everything in my virtual environment. This is about, you will encounter this problem even if you are completing, one simple Python script and not referring to anything outside the text editor. And the big problem there you alluded to is an awful lot of the time, the programs we are in the middle of writing are syntactically invalid because we haven't finished writing them yet. And if you feed a syntactically invalid program to a parser, the typical result you will get is a loud explosion and an exception raise. This is obviously not great. I mean, it does help. Again, it allows that inline, help in your editor. You can put a little red squiggle underneath a particular line and say, syntax error on line 4. But what you really want is to nevertheless be able to provide some useful completions. And this gets into the thorny area of error recovery in parsing. So the idea here is that you can write a parser that blows up on a syntax error, or you can write a parser that sort of guesses, it knows that it's hit something syntactically invalid, then it goes, well, there's a syntax error somewhere around here, but can I sort of squint and still parse the rest of my program? So this could be as simple as, like, I am just going to forget that the line of code on which this error occurred even existed and see if the program parses if I get rid of it. Or you can go into basically arbitrarily complex stuff about, I think they've forgotten a comma here. If I inserted a comma, at column 14, then the rest of this code parses. So I'm going to cross my fingers and parse this code as if they had that comma there. And then later I'll tag this with the syntax error saying, by the way, this is a best guess. But it's always a guess. You have some partial AST, and what you really hope is that there is enough information in that AST that you can still gather the information you want for code completion about things like, what variables are available. Like, that's roughly how you cope with errors, is you spot them, you try to recover from them by fair means or foul, because again, this is an approximation. You only need to keep the computer happy. There is no correct answer. It's a syntactically invalid program. You just have to come up with an answer that you can get away with. And then you parse what you've got and you ignore the syntax error token and serve the user your best autocompletion. And sometimes it will be nonsense. And your hope is that most of the time it's better than just giving up. So that's handling partial code. You also asked about a sort of interesting one about how you prioritize the results you get back, how you'd rank suggestions. And I can see how that sort of makes sense as a question, because it feels almost like a search engine when you want to rank suggestions. But the thing about a parser-based code completion, classic code completion, is that it's part of the editor. It's kind of being used sort of, halfway to the brainstem by the programmer. They're not thinking about your code completion, which means that it's really quite important for your code completion not to try and be too clever. If the programmer is using code completion for discoverability, they are typing requests dot to find out what functions are in this module they've just imported. Sure, yes, it's useful to show them the stuff they might be interested in first. But most of the time, a program will be typing req tab, and your code completer's job is to ensure that that actually produces the code they want. And if you're trying to be too clever about it, you're going to trip them up because you will no longer be predictable. If they typed request.ga, they're confused, they're at the wrong place in the listing, they want to know it's alphabetical so they know they go down in the list of possible completion to get. So I think really prioritizing completions, except for sort of broad things like you probably are not interested in the dunders, so sort of sort the dunders towards the end of the list. Apart from broad things like that, prioritization, we restrict prioritization to we get one guess of, if you type sort of self dot or anvil dot, what first completion should we start out highlighted in that little drop-down box of possibilities. But beyond that, it's an alphabetized list. It completes prefix matching first, and if you hit the tab key, it will complete what you expect. That's what the program is going to want, hitting a new key. In some cases, it's in almost single-digit milliseconds. They don't really have a lot of time to interpret what your code completer's pulling up, so you want it to be predictable.
In terms of that timing aspect, there's also the question of, and this is probably more of an editor question than a completer question, but how soon do you want that window to actually pop up and give me a suggestion? Like if I'm typing and I know what I'm typing and you pop up a suggestion, I'm just going to get angry.
Oh boy, yes. It's an excellent question, isn't it? I'm not going to pretend that I have the answer. That's, again, that one is one of the questions that illustrates how far we are into the land of your job is to keep the human happy. There is no objectively mathematically correct answer. Typically, answers you see are things like if they pause for a certain number of milliseconds, you pop it, or if they hit the tab key or control space or whatever their hotkey is, then you pop it instantly. Or if there's only one completion left at that point, you do the tab. Even then, that causes edge effects. That means that, typically the tab key will insert the currently selected completion if there is one popped up. So they can be, 1 millisecond either way, and the tab key either pops up the little list or it causes you to complete the first thing on that list that just popped up. And again, get the wrong one of those and you make the programmer angry. Yeah, I'm not going to pretend I have any hard and fast rules there. The answer to that one is just use a test. Sit somebody down in front of your program and see exactly what shade of purple they turn as they fight with your autocompleter.
Going back to the question of indexing and, understanding how frequently you want to rebuild the index for which pieces of the overall space that you're trying to work with, that gets into the question of there are two hard problems in computer science, naming things cache invalidation and off by one errors.
Yep, and autocompletion deals with both of them.
Yes.
Absolutely. I mean, yes, this depends on your strategy for how you're dealing with the dynamism. There's also all sorts of things. We encounter some problems shaped like this quite a bit in Anvil, which is that if you have two components with a mutual dependency or mutual recursion, or typically the thing you'll find in Anvil app is that we have two forms, two of the views, chunks of UI, and one of them is embedded inside the other. There's this list of components on the screen. You've initialized it with a bunch of rows you've just got back from a database. And so obviously, when you update the code that reads from the database and plugs the result into that list, you want to make sure that you propagate that information so that when you're editing, the template for each item in that list, you get all the nice code completion for, hey, what columns are available in the item I'm displaying. But also, when you click a button on that item, it opens another form to edit that. It's simple credit. That list is my to-do list, and when I click, I can open a detail page that edits that particular item from my to-do list. Well, now the type of that item that's been passed through is also now subject to change because I've changed something 3 modules away. And if I jump straight from editing module number 1 to editing module number 3, am I going to have stale information from my index because we haven't worked out we need to reparse the one in the middle that transferred that data around? So yes, hard problems all, mostly heuristics. Honestly, if I want to think about, what surprised me in building a code completer, probably the biggest surprise is how well cheating works. So you're approximating, you can't rebuild everything anytime something that might touch it gets edited, because you'll be re-indexing your entire app on every keystroke. But it really is remarkable how far you can get with pretty simple heuristics about, for example, when to rescan what, or even, guessing what the program is going to do, or even like backward references. So, if you're editing something further up the file, but, you're using a function to find further down that file, well, how exactly do you sort of know about what's later that early in the parse or that early in the scan? And again, it turns out really simple heuristics like, just parse it twice. I mean, they don't get you all the way there, but they really do get you very close for most users. So yeah, I'd say, to answer your question about things, order do you scan things, how do you deal with X computationally intractable, theoretically impossible to solve perfectly problem, the answer is you cheat, and often you cheat dirtier than you might think.
Digging more into some of the implementation details, in your presentation and in the conversation we've been having so far, we've been talking a lot about using some of the built-in machinery in Python to be able to parse the syntax and turn it into that AST, which is part of the standard library. Different languages might have different AST representations or different ways of structuring their trees. And I'm wondering if you can talk to some of your thoughts about being able to generalize across the space of, I want to write a code completer that works for different languages, and how heavily to lean into the machinery for a given language runtime that you're trying to target. And then as part of that, how you think about the architectural elements of designing the actual code that you're writing to write the completer for other people's code.
Yeah, roughly, if you're writing a completer, are you writing a single language or a multi-language system, or something you're expecting to plug in multiple languages to? So when we talk about parsers, I talk about the Python parser. It's not actually usually a handwritten piece of code that grubs through bytes and uses an algorithm to turn this into an AST. Usually, instead, what you get is you use a parser generator. So if you look into the Python documentation, you'll find something called a grammar file. And this is a textual representation of every structure that could make up a valid Python program. So, for example, you can find the definition of an if statement. And this is the file that says the definition of an if statement in Python is the word if, and then an expression, and then a colon, and then a block of code, and then maybe an else statement and another block of code, maybe an elif statement and another expression and another block of code, maybe nothing at all. And you can drill into that and you will find the definition of what exactly makes up an expression, and or it will describe to you all the symbols you can combine and how to make a valid Python expression. And then this exhaustive text file, which goes on for pages and pages and pages, you can then feed that to a parser generator. And that is a program that reads in this grammar file and spits out a parser. So it spits out the code for a program that reads in your program and spits out an AST. It's all extremely meta. And there are absolutely frameworks for sort of parser generators that are explicitly aimed at syntax highlighting and code completion tasks. There's one called Laser, which is Lezer, which is CodeMirror's version. And there is one, Tree Sitter, which is one that's built in Rust. And these are projects that are designed to take a syntax description of almost any language and then spit out a syntax tree. Now, the syntax trees they spit out are less nice to work with than something like Python's AST, usually because they are like a concrete syntax tree, which is to say that the actual structure of the objects that's produced is derived very mechanically from the grammar description. And unlike the way that Python's parser works, most ways to specify the grammar of a language in a generic way will produce some rather ugly syntax trees to parse, which means that if you're writing the completion engine that crawls over them trying to understand what's going on, then you're in for a slightly more painful time. But of course, however this is done, the tree at the other end is the shape of that tree is going to depend on the language you're building. So you can't really abstract out understanding of the language. The language has its own rules for, things like variable scoping. things like, where you can use a function, how arguments work, what syntax is even available. And I can't speak to how people like JetBrains have done it, because they build a very good code completion system that's used across their fleet of IDEs, PyCharm for Python, IntelliJ for Java. They have one for almost every language under the sun these days. And I imagine that they share some components, but my wet finger in the air guess, and I'm waiting for Paul to email me as soon as this episode goes live and tell me I'm wrong. My wet finger in the air guess is that there's actually quite a lot of language-specific code, because you need something that really, like code that's walking through a program, understanding what it's doing, kind of needs to understand what that programming language is about. Otherwise, you're going to have sort of approximations caused by being generic, and that's going to read as quite unPythonic if somebody's writing a Python program. So my guess is that there's actually relatively little you can do to try and handle multiple languages at once. I think that probably the only bits that you could abstract out are things like the parser, which is why there are projects like Laser and Tree Sitter. But I think that building a good completer certainly is a more artisanal process of trying to actually understand a program and working out exactly how much you can infer from a statement in any given language. And I don't think you can really replicate that automatically.
To your point of, every language environment has its own vagaries that need to be accounted for in the completion engine. I'm sure that there are also elements of the ways that you think about indexing those semantic structures in a way to make them accessible to those completion engines that raise the bar for being able to have any sort of common standard for that. I know that for at least some subset of languages, there is the C tags approach, which started for C as an indexing structure. Some other completion engines try to lean on that, generally with varying levels of success. But, to the point also of, in order to be able to index the entire list of tokens that I might want to complete in my program, I have to first download all of the associated libraries into a virtual environment so that I can then crawl all of those and cause my fans to go into turbo mode for an hour to build up those indexes. Wondering about the viability of being able to, even within a given language community, say, okay, this is the standard index format for being able to represent all of the tokens that might go into a completion engine. Those now get compiled into those packages so that I can download those as a metadata file, or fetch them from an API so that my completion engine can give me those tokens without actually having to download all of those files, rerun all that index, and waste all of that compute energy across any number of thousands of machines, turning that into some sort of standard reference so that I can have a completely empty virtual environment directory, start typing, I'm going to build a Django application, and have all of that code completion in my editor, from the moment that I start.
So I do know that, again, the JetBrains family, tip of the hat once again, their Java IDEs do have prepackaged indexes for some libraries, I believe. But generally speaking, I think what you'd be asking there for getting different completion engines to interoperate is kind of asking them to standardize on their internal data structures, which I think is a bit of a big lift. I think that's probably best done within one completion engine, which is more feasible for a giant. So I could absolutely imagine Microsoft's completion engines for common languages to do that and have some kind of central repository. In general, I'm not sure that would be useful. Certainly, as someone who wrote a completion engine for idiosyncratic reasons, I guess we would make use of such a repository were it available, but the very first thing we would have to do is basically translate it into our world, because this is the thing we know from things like the Language Server Protocol, or rather the existing LSP service out there. There are ways that most completers think about code that aren't particularly handy for some of the bits of information that Anvil wants to inject into the completer's knowledge. And I can hardly imagine we're unique here. If you're writing a new completion engine, it's probably for a reason. Therefore, probably don't want to share your central implementation with the previous guy.
Well, in terms of your experience of building a completion engine, working with end users to understand the utility of that and where you've gone wrong, your work as a developer, experiencing other people's completion engines, what are some of the most interesting or innovative or unexpected ways that you have seen code completion used and applied to enhance or augment the developer experience?
I guess it's probably safest to toot my own horn here and say something that I'm quite proud of was that integrating like code completion into the Anvil UI editor, so that you actually, when you're like saying, okay, how do we set a property of a particular component on the screen, that's actually a Python expression, and that's got like the full code completion engine with context from the rest of your app attached to it. That's something I'm pretty proud of. I've heard some really fun things from companies with absolutely gargantuan code bases where, just like, downloading all of the code in a, Amagoo faced soft repository just to index it when you're using common libraries is, that would be a bit of a challenge. Even downloading the indices for all of those would be a bit of a challenge. And I have heard of some quite fun things being done in those environments to try to provide a good auto-completion experience, despite it not being a sensible thing to do to drink the ocean and parse everything that's on your Python path. So, yeah, some of the stuff I've heard from there is pretty cool as well. I think really anything that gets you just like an incrementally better understanding of what the programmer might do, what options are available in front of you, is always going to be a win.
In your own experience of working in this space and building a completion engine and shipping it to end users, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think I've already answered this. By far, the biggest surprise is how well cheating works. You can use some remarkably simple heuristics, and it will give you remarkably high fidelity code completion.
What are some of the situations where either building a completion engine or applying code completion to a problem space is more effort than it's worth, and you're best suited to just read the docs?
Almost never. I do think that a code completion engine is the best index into your API docs anybody will ever use. But I do say API docs. This was, in fact, the subject of my last year's PyCon talk. But there are different sorts of documentation for a project. If you are using code completion, you're using effectively API documentation. Like, you are answering questions, what functions are in this module? If I grab this object, what attributes will it have? What arguments does this function take? And that is good, but that's not all of the documentation of a project. If you're building a project for yourself, you're going to want some tutorial, some high level, like from the beginning, teach somebody the ropes, show them around. You might want some how-to guides to accomplishing specific real world tasks. You might want some reference documentation that's not actually API documentation. People confuse the two a lot, but is sort of more of a description of the machinery and how to operate it that isn't necessarily information that can reasonably be conveyed as a little bit of description of a particular variable, because that variable is part of some big machine. So the example I use here is if you've got some unit testing library, it has some concept of a code fixture. So you run some code to set up your test environment, you run a test, you run some code to tear it down. That piece of machinery needs reference documentation. What it does needs to be fully specified, but you can't actually get all the information about how that library works by looking at the API docs for the at test.setup, at test.test, at test.teardown decorators. You need some higher level reference, or not higher level, but some reference that describes that whole piece of machinery. And so that's an example of information that you can't really get out of a code completer. You've really got to go jump to the docs. But for the docs that are shaped like that, for API documentation, for describing individual code objects, there's really nothing better than a proper code completion.
As you continue to support and iterate on the completion engine that you have found yourself maintaining and owning, what are some of the things you have planned for the near to medium term, or any interesting areas of exploration that you have slated?
There's always the ongoing maintenance and, the completion engine should have inferred that. The big, most fun thing that's happening at the moment is that there is a rewrite ongoing of Sculpt's parser. So Sculpt, that's the Python to JavaScript compiler, and we used Sculpt's parser as the front end for Anvil's autocompleter, and that parser is being rewritten. I'm one of the maintainers of Sculpt, so I am involved in this effort, and a couple of goals. One is, of course, going to be to give better fidelity to new versions of Python. as the language grammar changes. But the thing I'm really excited about is giving it better error recovery so that our code completer can be better at sort of seeing through syntax errors and giving the user a little bit of help regardless.
Just to kind of be devil's advocate, why not just decide to use PyScript and let it do the parsing for you?
I mean, the PyScript parser would have been a legitimate choice. If people listening aren't familiar with PyScript, might as well give the thumbnail. So PyScript is the full CPython interpreter compiled to WebAssembly and then used to drive an HTML page. So it's basically using Python instead of JavaScript. So you open a PyScript file, your browser downloads like all of CPython. It's fairly chunky, which is one of the big problems with it for some applications, obviously not for others. And then it runs a full actual, like the same Python that runs if you type Python on your command line, running the same thing in your browser. And then, it's got APIs for driving the HTML elements in your web page and so on. So you ask, why not use its parser? I mean, actually, perfectly reasonable. Something like the Anvil IDE, it doesn't really matter if it's downloading 16 megabytes of Python runtime. And had PyScript existed back then, that would have possibly been a reasonable answer. I mean, as it is, we kind of benefit from having overlap between the compiler that executes the code of Anvil applications, which is pretty lightweight. I think the core compiler is under 300 kilobytes on the wire, and we can break down the standard library and download it in chunks when the user wants it, so it can load faster than the WASM'd version of Python. So there's good reasons for using that for the front end of apps built with Anvil. And once we're doing that, there's really a lot to gain from sort of reusing that component and gaining familiarity with the one component rather than trying to be deeply familiar with both.
Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. This week, I'm going to choose Weird Al Yankovic. I recently kind of rediscovered him and have been enjoying listening to some of his songs with my kids. So if you're looking for some lighthearted fun and some interesting takes on different popular songs, always worth giving Weird Al a listen. So with that, I'll pass it to you, Meredydd. Do you have any picks this week?
And he is such a good musician
Absolutely.
as well.
It's
it's really technically well executed. Yeah, full marks to him. My pick for this episode is going to be Timescale DB. So generally speaking, I'm an advocate of keeping your infrastructure environment simple. Like if you're maintaining a zoo of different sorts of infrastructure elements, then the chances that one of them is going to bite you keep going up. And historically, I've tended to, if a problem can be solved with Postgres, use Postgres for it. There's this line people use about Python is that it's the second best choice for everything. And I kind of like that. It's the way that learning Python gives you a good all-round capability. And in the same way, Postgres is kind of the second best choice for everything involving data storage. It's not a NoSQL database, but like its JSON store is close enough that it might as well be. And one of the few areas where that wasn't followed through was like high density time series data, which Postgres historically coped fairly poorly with. And then Timescale DB came along and made a Postgres extension that turns it into a pretty good time series database that you can use with all the Postgres tooling that you've become familiar with. So yes, we are big fans. We use it for a whole bunch of logging and time series work in Anvil, and it will, I think, remain a tool I reach for many years to come. Even better, they have just released, I haven't had a chance to properly get to grips with it, but they've just released PromScale, which is using Timescale DB for like monitoring, application monitoring and tracing, rather than bringing in, like we use the Grafana stack, so things like Tempo, storage engine, so on. But if you can store your traces in Postgres and like query your application tracing in Postgres, again, like everything gets better. I really like using the one tool for everything, and Timescale DB drastically expands the set of problems I can use one of my favorite tools on. So yeah, that's my pick for the week.
All right. Well, definitely second your commendation of the Timescale DB folks. Definitely a good product that they've built. I actually had them on a couple episodes of my other podcast, so I'll add links for folks who are interested. And so definitely want to thank you very much for taking the time today to join me and share your learnings and experience of digging into the space of code completion. It's definitely an area that is obvious as a developer of when you're using it, but can often be mysterious and appear to be a black box if you don't dig into it. So thank you for helping to shed some light on that, and I hope you enjoy the rest of your day.
Thank you once again for having me. It's been great.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.